Hello, and welcome to my talk on getting started with interactive reporting, building dashboards. My name is Anthony Zupnik, and I'm a software developer at Wolfram, and I've had many different roles over my 10 years here. Part of those roles have been creating user interfaces, a lot of end things that end up being what you might call a dashboard or a report. So it seemed like a good fit for me to deliver a presentation like this. So I'm kind of I don't I don't know like the skill level of everyone here. It's been marketed as a beginner level, so I'm gonna try and keep things relatively simple, but also show some interesting tips that might be useful for different for more advanced users. So hopefully, this isn't going to be too boring for intermediate users either. My aim is to show a multitude of things. Now, if you have any questions, if you're, please ask away, and I will answer them during the course of the presentation. This is a interactive presentation. It's more like a sort of like a course in a way, well, a short one at that. So let's get started. So I decided to deliver this presentation outside of the presentation view. So it's not gonna look as nice, but when it comes to coding, I much prefer. I like to have a long notebook to work in. The presentation mode is just sugar for stylistic purposes. Um, so so yeah, let me tell you what we're going to go through. We're going to outline what a dashboard is, uh, get short talk about the kind of data that we can get natively through the Wolfram language or through external sources. Talk about layouts for your dashboard because that's primary concern to a lot of people is how do you lay these things out. Briefly, I'll show you some styling choices that you can make. There's a lot of styling you can do to your dashboards to make them look really nice. So I will be keeping it relatively brief, as I imagine that time will be a factor there. We'll talk about deploying. Oh, well, these have links. Static content and dynamic content. Part of the benefits of the Wolfram language is that uh, with Wolfram Desktop or the Wolfram Cloud, you are able to create dynamic content, which is quite nice. But some people prefer static content, so we do static content as well. We'll talk about different types of delivery for reports. Now, report is going to be a very general term here. We have our own software for report generation, which isn't covered in this talk. It's going to be covered in another talk next week, which I'll mention at the end of this talk. But we'll talk about some basic type reporting so that you can get started. A little bit on troubleshooting, and provided that we have time, we will go through an advanced example which uses some more advanced programming techniques to create a little dashboard. So first of all, what is a dashboard? Now, it's a very broad term. I mean, if we can go on Google and Google what a dashboard is, I mean, what we can see is, basically what we've got here is we've got a grid of stylized plots and charts and stuff. It doesn't have to be plots and charts. It's just any bits of information that are displayed in a nice user-friendly way. So important skills to be able to create a dashboard is to arrange things in grids and to stylize it. So those are the main things. And then, when you want to add dynamic content, you may want to add some interactivity to these charts. This is I don't know if this is an interactive chart. I'm not sure. Just using this as an example. So, in the Wolfram language, let's say we've got, we can have a static chart. So here we have a dateless plot, which looks at GE, which I think is General Electric, the stock price from the year 2000 to date. This is a static chart. It does actually have, I say it's static, but in the recent version of Wolfram language, we actually added these tooltips, which are automatic. I guess these still count as a static, but it's quite nice to be able to hover over this over this chart and actually see what the number is, the x and the y axis value. And now we can make the chart dynamic with interactive shading chart. Now this is a very specialized dynamic piece of content specific to trading. It's if you look at the documentation for interactive trading chart, it will show you a bunch of examples which use use our financial data to generate some stuff. So here we have, we can scroll along, change the size of our plot. We can highlight over, and you can see at the top that we get the high, low values, etc., and it's quite a nice little chart. And what we can do as well is, so this is like our static, our dynamic content. Now we need some kind of deployment options, and one of the things that I mentioned at the start was the Wolfram Cloud being able to deploy dynamic or static content to a website, essentially, which you can go to. We call them cloud objects. If I run this, we're going to deploy our dateless plot to this URL, and if I click on this URL, and now I've added no sugar here, so it's a very plain chart. But we have our chart that we had from before in basically on a website. So word on getting data. Now, one of the advantages of the Wolfram language is that we are able to, we have one of our slogans is where computation meets data. In fact, if you probably go on the Wolfram webpage, you'll probably say that, and quite big somewhere. And the reason why this is important is because we care about creating a language, but we also want to make life easier for people. So one of the things you obviously, when you're creating a programming language, is you make a bunch of utilities for people to be able to make content themselves, program themselves. So you make more advanced functions to be able to solve problems, but you can also make algorithms, which are like a number of functions put together to solve a specific problem. And the algorithmic data that we've got is quite strong, but we also have general data to be able for you to be able to use within your functions themselves as well. One of these things is example data. So this is probably one of the first functions that we ever made, which created was a repository of data for people to be able to access to test their functions with. So if we look at example data, we can get aerial images, for example. I'll just copy this out and go for aerial image. And we can see that there's just a handful. Let's see how many there actually are. There's 38 examples of images, and we can get an image of Earth if we want to. So here we have our example data of Earth. And, the good thing about this is we can assign this to some kind of variable, and then we can, what is it, binarize? I'm just trying to think of an image manipulation function where we can grab data from our example data repository and then we can do some kind of manipulation on it. So there's lots of different examples here in example data, but this was just the beginning for us. We started to to organize the data in a user-friendly way. We released Wolfram Alpha, which allowed us to grab data and do some kind of manipulation of that data. So, for example, this is just a Wolfram Alpha cell. I press the equals sign, brings up a Wolfram Alpha cell, and I can say, number of cows in the UK. This calls Wolfram Alpha, and then it gives us it converts my natural language into a piece of code, which is quite useful. So now I've got a piece of code where I can look at these this piece of code here is an entity, the entity being United Kingdom, and then I can get a property from that entity, which is the livestock population, specifically the livestock type being cattle. Now, when I click on that, it converts into code. So one thing you can do is press Command Shift I on the Mac, and I think it's like Control Shift I on Windows, and it will convert this into a a form which doesn't have any sugar. So that entity property thing now has been converted into raw code, so that this is something that you could write yourself. So yeah, now I can change this to France if I wanted to, and it would return the number of cattle in France. So a lot of the data that we get from Wolfram Alpha can be converted into is in this entity form, which is more curated data, which is organized in a way that you can start to do more robust calculations with. So yeah, and Wolfram Alpha, I don't know if you've used Wolfram Alpha before, but if you press equals twice in Mathematica, you're able to get a full Wolfram Alpha query. And what was it? Number of cattle in the UK. And if I run this, what we'll find is we get full a full Wolfram Alpha query within a notebook. So yeah, we can extract this data out, and it's made a plot for us. It's given us additional information in case we were interested in additional information. But if you use the single equals, then you can basically, the single equals is very nice. If you're unfamiliar with the Wolfram language, it can be a lifesaver to be able to generate a piece of code for you. If you don't know how to do it. So, for example, if I wanted to, solve the equation 5x squared plus 2x plus 3 equals 0, we get the solution, but we also get the piece of code, so that I no longer have to do a Wolfram Alpha query. Because if you're using a Wolfram Alpha query, it has to process that natural language first, and then do the calculation. Now, if I click on this, it will remove the Wolfram Alpha and the natural language part, and just leave the code. Anyway, I digress. So So those are like the I mean, we also have all these repositories as well. We have the function repository, the neural net repository. We have all sorts of ways of getting data into a Wolfram language notebook. But you may not want to use our stuff. You may have your own stuff. So we have many different ways to interact with other data from other sources. One of them is import. So this is importing an Excel file, which just has some a bit of a strange piece of data, but it was a list of gibberish words in some kind of comma separated way. So yeah, you can import all sorts of files nat directly into the Wolfram language. If you're interested in what formats we can import, you can just use $import formats, and you'll get a list of the types of data that you can actually import. And likewise, we will talk about this in a bit later. Export formats gives a list of export formats, so you can natively translate a Wolfram language expression and export it into the format of your choice. Now, we've got a number of ways that you can use our Wolfram products to store data. One of them is using the Wolfram cloud with, well, Cloud Put, for example. So we have this lorem ipsum text, and we are putting this into a file called example file. And if I'll just run these separately just so you can see when I run this, we are storing the information into a cloud object. And I'm just now pulling that information back, and it'll be the same thing because I haven't changed the data in any kind of way. What I can do as well is there are these things called cloud symbols, where you can set a value and like a variable, but a global variable which exists on your cloud. Where I've set the cloud symbol X to 12 factorial, and if I call this back, I will get 12 factorial. So this cloud symbol is stored in the cloud. There's also this thing called the cloud expression store, which allows you to store data in cloud expressions, which are much faster at accessing. So if you care about speed of accessing data, the cloud expression store can be quite useful. And if you're interested in like large number of small bits of data, we've also got the Wolfram data bin, which allows you to create a data bin. Let's just create how do I do this? Create data bin. db equals data bin, and then we can data bin add a piece of data to that data bin, random integer, and let's just add a few bits of data to this. Just run it a few times, and you can see we've got 5 entries. And now if I get this data, we should find a list of the zeros and ones with a bunch of information of when the data was recorded, where it came from, things like that. And you see it's came from a Wolfram client, things like that. So if you're looking for, like you have a sensor and you're pushing data to a sensor, the data bins can be quite useful. You can use import to, I used it to up here. I used import to import an Excel file, but you can use it to import website information. So it knows how to handle this. So here, if I import our Wolfram language symbol, I can just use import for that. There are various, each import type has different types of of things you can get out of it. So for example, I'm going to import wolfram.com, but I'm going to import the data from wolfram.com, and it's done some processing to convert this into a bunch of lists. But I won't go into too much detail there. If you really care about import like fine tuning how you get your data from websites, there's a function called URL read. URL read allows you to send an HTTP request to a URL and get a return. So this allows you to do get, post requests, things like that. It's quite useful. This is the main function I would use when I want to grab data from a website. It allows you can fine tune this a lot better than import, but import is useful if you are a beginner. So let's talk about layouts now. So I've talked about the data, how we could get data, and now let's take a step back to what I said before about what a dashboard is. And what a dashboard to me and a lot of people, I think, is basically data laid out in a nice user-friendly way. And to do that, we basically need grids, and we need to fill out those grids with stuff. So we have a number of functions to be able to do this. We have the grid function, which makes our grid. So here we have a grid which has 4 strings in them, and they're laid out in a grid. It's a matrix, and we can do a column. Column is just obviously a single column of data, and row. Here we're creating a row with a spacer, which I can increase the size of if I want to, which is fine. Now, a note on this, it's interesting. I mean, I would tend to choose to use grids for pretty much everything, unless grid doesn't really supply the relevant information. Now, the reason why is because grids are the main function that we use for laying out data. Row is interesting. Now, we can look at the contents of this data, what we call this is kind of like this typeset form of this data. The underlying language to display this cell is I don't remember what we call it. I mean, I call it box data. Like, and if I press Command Shift E on the Mac, I can see what this how this result is displayed. We can see that there's a grid box with our example 1, 2, 3, 4, and it's got a number of other settings to help describe the typesetting of this grid function. So you see that this uses a grid box, column uses a grid box. Now, row is a strange one. It uses a template box with row with separator. So it's kind of using a different language to describe a similar thing, because a row could just be a grid with just one with just one list in it, and it will look relatively similar. And if we want to do the spacings, I'll show you how to do spacings in a minute. So I'll close these, and we'll look at grids. We'll use a mixture of grids and columns here just to show you, but my recommendation is try and use grids as much as possible, and only use column and row as more of a last resort. And that's my thoughts on the subject. So we can add options to grids. So the core values of the core value of grid is this list of lists, whereas if you want to add additional optional data, that's applied supplementary at the end. So we can add various different options, and these can be ordered in any way. Oops. And they just apply the options to this grid. So what do I want to mention here? So this data can be anything. This data can be it can be an expression of some description. I mean, it can be a random image. It can be a number. It can basically be anything. And it will grid works in a way where it will automatically fit the boxes, fit the content to the boxes unless you specify otherwise, which we'll talk about in some detail, because you may not want the grid to automatically resize in certain situations. Now, one thing we can do is with grids is we can nest grids. We can nest grids with any expression, and it all works fine. So here we have an example where we've got our example 1, example 2 before, but we've added a row with some values, which is our row from above or similar, and we've added a column as well. And yeah, we've used this frame goes to all to kind of show how these boxes are actually made. So when we run this and we've added frame to all to each of the row, the column, and the grid, we can see that example 1 is this row with this 1.2, 1.2 here, and our column, and we can add more data to this if we want, and it will expand accordingly. We can increase the spacer here, and we'll see that the grid expands accordingly. So what we can do is we can use these grids or columns in the next example, using grids of grids to create some kind of like web page like structure or dashboard like structure, I suppose, to arrange our content. So what we have here is we have a header, we have a grid with a kind of menu. If you wanted to have a menu where you could click some items to change dynamic content, we have a right menu area, and then we have a footer. Now we use these things called span from left, and there's span from above as well, which basically means, let's say I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's say I wanted to have one in this space in the center. Now, what I would do is I would get rid of this value here. But if I get rid of this value, what's going to happen is it's going to take the spot of where 4 was. Whereas if I use span from above, what that means is look at the content above and kind of like merge it together, like merging cells in Excel. So we'll see that we've merged the cell, and if I go frame goes to all, we'll see that there's an individual. There's no. It's just one cell, and then if I change this to span from above, then we will we'll get rid of that. We'll get rid of that 6, so that 7, and link these cells together. Likewise, you can use span from left to link two cells that are next to each other. The other thing you can do is, let's get rid of this one and convert this back to 7, and we want to get rid of the 5. We can span from both, which spans from left and above, and we change the 2 to a span from left as well, and that will merge the that'll make like a 4x4 cell here. Now, if I wanted this to be centered, I can use the item function or expression to designate that this is an item within a grid. It's kind of implicit. But if you want to add some additional options to that item, you need to wrap it with item, and then I can add additional options. So I can now say alignment goes to center, and now we have a one which is center to the whole grid. So when I run this code, we can just see what it looks like. We've made, this, as I said before, kind of a web page based sort of structure where you have a header, footer, you might have a menu, and then you have some content. Now, this is kind of small. It's kind of what the Wolfram language is doing is it's kind of got some default settings for how to space things out. So there's some padding and some spacing options that are automatic to a grid. So really, it's just trying to create a grid in the smallest amount of space possible with some padding. Because obviously, if you make it too small, I mean, this could be done a bit smaller, but it would look horrendous because things with no padding just don't look very good. In actual fact, I wonder if I can just do padding goes to 0. Is it not? Just trying to think what the options were here, and we can see potentially how padding. I think you can definitely do spacings goes to 0. Okay, so that's made them a bit smaller from before. There's some other options as well. Just so you can see, I'm just looking at the documentation for grid, where you can see that there's options for spacing, and I'll talk about this in a bit more detail in a minute anyway. So anyway, to set sizes, we can use things like, well, I've already discussed item, and we can also use pane. Now, pane allows you to fix a size for a piece of data. If your data ends up being too big or something like that, and you want to add scroll bars or whatever, you can use pane. So let's say we've got pane with 100 factorial. Well, it doesn't really do anything at the moment because we haven't specified any options for pane. So let's do this autocomplete thing here. So when you just so you know, if you're unfamiliar with this, you can type in a function name, and then you can press Command Shift K or Control Shift K on Windows. It brings up some templates which allows you to fill out a template. So here we can see we've got pane, which makes a pane with a width of W and a height of H. And we've got 100 factorial here, and I can tab through, change my width to 100 and my height to 100, and we'll see it's kind of compressed this into a 100. I don't think it's 100 pixels. I think it said what it was in the description, which is it's in points. Points, I think, is similar to the points that are used in text. So I could add scroll bars, for example. Scroll bars go to true, and then we've got a scrolling structure where actually we can resize this, which is kind of nice as well. So here we have a grid, and we have a very similar structure to what we had before, but we've added some additional item information. So for this grid, we've added we've wrapped item around this around our X, and we've specified the size to be 5 by 5. Did we add some alignment issues, or the alignment issues were already there? We've also added some alignment issues. We aligned to center. We've also created a pane around this grid so that we are specifying the size, and we're using image size in this case, and image size works in pixels, so we're making it 250 pixels wide. Here we've got a framed pane, so we're using the framed option expression, which basically wraps a frame around any expression. In this case, it's wrapping it around a pane. In our pane, we are making it a full-sized image, so to fit the fully fit the content that it's that's in the that it's trying to display. We're center aligning it, and then we're adding some margins, making them 50 points wide. And that's it. So when we run this, what we'll find is, image size full. Sorry, that just fills up the rest of the the full space of the notebook. So if I change the size of this, we will see that it fits the content, which is kind of nice. So yeah, so for, frame margins, if we were to change this, we're changing the margins of the pane. So that changes the margins in all directions. You can only see it in the vertical direction because we're already like maximum padded out based on the image size being full. And what we can do, actually, just to show you another way to do these things, is let's say we have a grid of 1, 2, 3, and you wanted to specify the width of an item. You can change spacings, is it? I'm going to remind myself of what the option is for item size. Item size goes to full, and that should and I need to wrap another list around this. No, never mind. I think this is what I wanted to do. Spacings goes to. So if I say scaled, okay, never mind. I've forgotten how to do this. Basically, you can use scaled in certain ways to specify the size of something based on. Well, you can do it based on points, but you can also do it based on the size of the of the notebook. Anyway, I don't want to run out of time here, so let's move on. So we've got our grid here, and we're gonna simplify it a little bit. We're gonna remove this left menu and double footer. We're just gonna add a single footer and a header and some content, and we're going to fill it up with data. So a grid can be filled up with any form of expression. Now, what you can do, I'm not sure if I recommend this or not, but it can be a useful guide if you're just getting started with Wolfram language. Let's say you've got your content, here. Now, one of the things you can do is you can just replace this string with your content. So let's say I change this to sin x 110, and it will fill it fills the content with my plot. But what you can do as well is what was this called before? It was called content. If there's you can use this this expression or function called replace all, which is this this slash dot, and you can feed it a list of stuff that you want to change. So what I can do is I can change content. Now I'll change everything with the string content. So this is a this really, you should only be using this for testing purposes in a way. Let's just change this to random image. And it will change, my string content to random image. And the reason why this you should be careful is, of course, if something else is called content, it's going to change it in every single place that happens. However, if you could treat these as variables and you give them, very specific names that you're never going to use anywhere else, then you can change this to random image here, and there we go. We've replaced our content, and you can just give this a list of changes. So we've got right menu. Ooh, let's change the Greek there. Right menu goes to. I'll just change this to Hello World, and we'll see we've changed multiple things using this replace all function. Now, obviously, what you can do is you can just replace the content, and this is what we've done here. We've taken our grid and we've added a pane which tells me when this expression last loaded. It contains a column which contains some stock information, so it uses our. So we've got this with statement which basically just says we're basically declaring some variables and putting those variables inside these values. So we've got current stock being GE, which is General Electric, and the date being the 1st of January 2000. And we're basically feeding those variables into this grid. And what we've got here is we've got a pane which is just some text data, which gives us stock price. It gives us the start date, which we're converting this date into a date string so that it's user readable. We're getting a dateless plot with the financial data, which is what we did very close to the start of this presentation. And then we're adding some additional stylistic options. We're framing everything so that you can see how things are laid out in this grid. And we're adding some exchange rate, the current exchange rate for pounds to dollars, and we're also getting the current stock data. So when I run this, it's got to grab all this financial data from the internet, import it, and then display it. You can see what we've got. So we've got, this was our header, our two footers, and then our internal information where we show the stock information. And we could change this. So we could change this if we want to something like, is Apple APPL? Is that going to work? Nope. Probably because I can't remember what Apple trades on. Apple stock price. And this is the beautiful thing about being able to use these things. I should probably just be able to give it this financial entity Apple. Actually, NASDAQ Apple. So I can just give it this. I think it'll be fine. Okay, so there we go. We've got a plot of NASDAQ Apple. We also see in this dateless plot that there's some clipping here at the top, and to change that we can go. I think we change plot range goes to full, and that has some automatic plot ranging here, which can result in some clipping. But if you can define your plot range yourself. If you use full, then it will show you the full amount. Right. Now, tab views are quite useful to being able to create more dynamic data, because right now what we've got a static plot really with nothing to interact with. So tab views allow you to to create some semi-dynamic content. So Command Shift K, tab view, Command Shift K, and what we can see is we can give it a list of labels with expressions. So we can have label 1 be A, label 2 be B, and we can add additional stuff. This is what this ... means. I'm just going to delete that. And we've got this little tab view where 1 is A and 2 is B. But obviously, we could have done our random image, and 1 is now a random image, and 2 is still B. And what you'll see in tab view as well is that there's automatic resizing based on the content of the data. Now, if you look at the documentation for tab view, you'll find that there are other options to be able to specify the size for tab view. And if they aren't sufficient, then you can start to wrap things out in panes and grids and things like that to have greater control. So what we've got now is we are creating we're using very similar code to what we had before. Although this time in our with statement, we are just using the date, and we are grabbing a list of financial stocks. We've got a function here which does a plot of a stock given a date, and we are doing a tab view which loops across using map, General Electric, Apple, and Tesla. Oh, did I just have to write Apple? Okay, well, I thought I did write Apple, but okay, fine. So we run this, and so yeah, we've designated a function inside a module. So module is like a self-contained, allows you to declare localized variables, and those localized variables can basically be functions. So we've made a localized function plot where we're gonna plot. We use that plot function to do a plot of the 3 variables, the 3 stocks: General Electric, Apple, and Tesla. When I run this, yeah, start date 2000. I can click Apple, and I can click Tesla, and you can see that it's given me this column which contains the plot and the current value, which I think we defined in the function. So the plot function gave a column of dateless plot and a pane with the current value of the stock with a bit of text. So this is just to show you some layout stuff. I'm not really going to go into much detail about styling at all, unfortunately, as there isn't enough time to talk about these things. But in actual fact, I thought I would have plenty of time to deliver this, so I was going in a bit more. I was going in a bit more detail in different places, and it turns out that I'm only halfway through the presentation and 50 minutes in. So let me speed things up a little bit. So style-wise, so I'll briefly talk about different styling options that there are for grids and items and things like that. So what we have here is we've added we are using various different things. So style is its own function which you can apply to an expression. In this case, it's going to be a string, and style 20 will set the size. So we can the first option is the size. I think if we look at the documentation, it's a little bit bigger. There are various different things that you can add to the as supplementary options. It gives you some examples here. So if I change this to bold, then it will make it bold, but it will make it small because I've gotten rid of this rid of the size. So what you can do is you can change this to font size goes to 100, and then you can say font family goes to whatever. You can probably change background as well, goes to red, things like that. The other thing you can do as well is you can give it a pre-existing style. So, for example, this cell here has a designated style to it. If you want to see what style it is, I think you can go to Format Style, and it tells you that it's a section. It's a section type cell. The other way you can do it is you can look inside the cell, which is Command Shift E on the Mac, and we can see that we get the styling is section. The second parameter to the cell is the style of that cell. So what was the style again? It was section. So the second parameter of style can also be the so it was was it? Well, whatever. We can just use subsection. The second parameter can be the styles. So if you like the styles that already exist in your style sheet, or you've created the style sheet specifically, and then you want to access those styles within Wolfram language expressions and not just the raw cell, then you can use the style function. Anyway, we've got a grid. And in our grid, we are adding some background information. So I'm going to expand this out so that you can see. Now, this is just a grid with like, let's say, a menu. And in this menu, we've got a header and some items. Now, the header, we want to be a specific color. So we've in background, you can using this. There's the specification is kind of it depends on like widths, and I think the first parameter is relates to rows. Sorry, relates to columns, and the second parameter relates to rows. Yeah, first parameter columns, second parameter rows. And what we're saying is we are alternating between this orange and lighter orange, and we're specifying that the first column is red. Now, if you don't like this kind of styling, which I'm much more of a fan of just seeing the raw code because I see everything as code, then you can use I use Command Shift I to convert these things into their Wolfram language form, and then it ends up being the same. So we can, if we wanted to change the third column, for example, we can just change this to a 3. It still does this alternating coloring thing, with the exception of the third value being red. And if I wanted to change more, then I can change this to, I can add another one. And do I have to give it into a list? Probably. So I add this now. So now I'm saying I changed the third column and the second column to be this red color. But yeah, the alternating colors are this list here. And you can give that more, it's going to just alternate between those two, but you can give it more alternating colors, and it will alternate as it goes through the rows, each of those values. Right, what else have we done here? So we, in our right menu, we're creating some italic content which has a gray and dashed border, and then in the whole grid, we are coloring the dividers, the dividers of the second and third column in gray, and we're setting a base style to be text, because what we have here is this font is a general font, is like a coding font style, and it's a little bit ugly. So what we're saying with all of our text items is that the base style is going to be text, and it's going to be Arial as well. Yeah. So what we've done here is we've created a bit more of a stylized layout where we can then feed content in if we want to. So there we go. There's a brief. Oh, we've added some rounded corners here as well. So rounding radius. It takes corners and rounds and rounds them off by some value, so we can make them more rounded, I suppose, by increasing this value, or less rounded by decreasing it. And we're making that that style red. So let's talk about some deployment options now. So this is kind of like what hopefully you'll understand now is have some basic building blocks to be able to create grids, set them out in a specific way, add additional content, add dynamic content, and add dynamic content, and then but we don't know how to deploy it yet. So at the moment you're only seeing that information inside a notebook. But let's talk about other deployment options. Now I've shown you the cloud, and we'll probably show you the cloud again. But first of all, let's we've got our financial dashboard. I think I assigned it to a variable up here somewhere. This thing here I assigned to financial dashboard, so I can call it up again here if I want to, just to remind you what it looks like. And this was the last time I called this. It was for the Apple stock. Now, if I want to, push this to a new document, because this is this is like my coding document, I can use create document. Create document with the financial dashboard. With this deployed to true means that you can't edit the content. That's what it means by being deployed. It's finalized content. I deploy this, and I'll just change the size here. We now have a deployed piece of content in a notebook. Now I can save this notebook if I want to somewhere, and that's fine. But what about how do I get people who do not have a copy of Mathematica or Wolfram Desktop? How do I get them to access that? Access their data? Now, one of the options is we can deploy this this thing as a CDF. So this is we have our create document from before, and we're using the export function to export to a file which is called staticscreen.cdf. And when I run this and I open it using the system open function, we are creating a piece of static content that is saved as a CDF, which can be opened with the Wolfram player. So the Wolfram player is a if we go click on this link in the notebook that you have access to. Although I guess if you have access to the notebook, but you don't have access to Wolfram Desktop, then you can open it in the Wolfram player. So you can go to wolfram.com/player. You can download a version of the Wolfram player, which allows you to access deployed notebooks and their interactive parts. The Wolfram player doesn't allow you to evaluate new pieces of code in cells, but it does allow you to access dynamic content and static content. But you may not want to download something. So if you don't want to download something, then we can use the cloud to be able to create a dashboard. To have our dashboard and deploy it for people to be able to see. So we'll just use wrap cloud deploy, and then we set a URL, and then it will go to a specific, well, it will go to, in my account, which is AZ, to dashboard/financial dashboards. And currently, if you go onto that link, you will not be able to access this. So if I go onto an incognito window and type this in, what you'll find is that I need to sign in. So, and that's because it is it is not available for public use. So even if I signed in with another account, it would tell me that I do not have access to it. So what I can do is I can change the options with permissions, and I can just say permissions to public. And what I should have now is I should have a deployed dashboard, which is available for the public to see. So let's just go to this link now, and we'll see that this this page loads. Right. So one thing you can also do is, if you there are a number of options for styling and things like that, and you can put this in an iframe, and you can place this on your own website or inject it into your own website or whatever. You may not like this, this branding here, so you can remove it. So appearance elements goes to none. Will change the branding. Will remove the branding. This is your product. This is the thing you made, and this kind of thing to deploy and stuff like that uses up cloud credits. So you're essentially paying for this thing yourself. So why not be able to remove the remove any sign that the Wolfram language is being used, and you can do so like so. You see, it's disappeared from the top. So I guess I haven't really shown like super dynamic content right as of right now. I've shown you tab view, which is like I called like semi-dynamic. I showed you the interactive. I guess the interactive trading chart was quite an interactive interactive piece of information. But we're going to go in and use form pages to create a interactive an interactive page which creates a dashboard on the fly. So what this does, form page, it takes a variable which I've called location. It takes an interpreter. Basically, an interpreter converts usually it's a string. It converts a string into a piece of data, often curated like an entity or something like that. I'll show you an example here. So if we say city, let's have a city interpreter, and we type in London, it's going to give us this entity back. So what it does is it does some additional computation here. It processes the string, and it then tries to find a city which aligns with that string, which is what I've put here. Now, interpreters can get very complicated. You can add restrictions. You can add all sorts of stuff. I mean, the interpreters can also do some computation. So it can do computed number. Let's see. So I say computed currency. I like computed currency amount. So what this can do is that's another layer of computation where, interpreter city really is just trying to, it's trying to interpret your string into into something that exists in our database. Whereas computed currency amount is saying, I want to do an additional computation on that data. So this can take, let's say, $2 plus 10 British pounds divided by, I don't know if I want to divide by it, but let's say plus 10 euros. And then I can even specify the amount, and I want it to be in yen. So these three currencies added together in and then converted into yen is 3,700 yen. So this is pretty cool. That it's looking for currencies, and then it's converting those currencies with the current exchange rate, which is quite good. Anyway, this form page takes a city where it's going to have a default input of Oxford, and then we've got our dashboard where we are basically having our last date loaded just to show you that it's up to date. And we are getting the weather data of that location. We're getting the temperature, the precipitation, the wind speed, the cloud cover fraction, whatever. I guess that's the percentage that of that the place which is covered by cloud. We're adding a title, which is weather data in a location. We're adding a description, and when I run this, we get a little box. Weather date. This is our title and description. We add the location. When I submit this, it asks me to review my choice because there are many cities which are called Oxford, although I think most of them are in the USA. In actual fact, there's one Oxford in Canada, the rest of them in the USA, and then there's one in the UK, the original Oxford. And we'll submit this, and we've got our little dashboard where Oxford is currently 17 degrees, 15 kilometers per hour wind cover, and I could change these. If I don't like kilometers per hour, we've got this unit convert function, which allows you to convert, let's just say one British pound here, into US dollars. Can I say? Yeah. And unit convert can convert is quite a versatile function, which allows you to convert all sorts of things into all sorts of other things. Currencies being one of them, but obviously kilometers to miles per hour, Celsius to Fahrenheit, if you use Fahrenheit. Anyway, so this form page is pretty cool. It really was designed to be used in the cloud. So while there is this kind of display form in Wolfram language, very good for testing, deployment-wise, the best kind of deployment is the cloud. So if I cloud deploy this form, and run this, we should get the same thing. And if we type in something like Oxford 2, for example, it's not going to find a city interpretation. If I run Oxford, we should get the same thing as before with our drop down, where we can select our specific Oxford. Let's go for Oxford, Ohio this time. And it's running the computation, and we got our little result, which is 12.2 degrees there with 7.5 kilometers per hour wind, and the cloud cover is 1. Wait, does that mean that it's like fully covered in clouds or fully not covered in clouds? Well, I don't know. But you can look that up. So this is kind of like this is an interactive form that we've got. I mean, you can make them very complicated where there's one result is dependent on the next. So if you gave it Oxford, it might give you a list of parameters relating to the UK, or if you gave it somewhere else, it might give you something else. So there's a lot of work being put into form pages, and they're very robust. Now, if you want to make dynamic interfaces yourself and not rely on form pages, the original functions for doing so were dynamic module. The dynamic module basically means, well, it's like module, but instead of variables, variables which are relatively static, you have dynamic variables which would be updated on the fly. So what we have is we specified a dynamic variable current stock, which starts at the UNH. I don't know what stock UNH is, but we're going to get a list of stocks starting with UN, and we get this list of UNF, UNFI, UNG, UNH, UNL, etc., etc. And we're going to bring a pop-up menu where you can choose that list from a list of stocks and create a plot of that financial data and change the current value and the plot and also the date that last loaded will change as well. So when I run this, what we'll see is we've got a dynamic thing where currently it's on UNH because that's what I started with, but I can change this to okay. Let's just run that again. So I'm using, one of the things that I did was I upgraded my version of Mac OS to the most recent version, and I'm using a older version of Mathematica, which is potentially causing some issues. So now I've changed this to UNH, and we can see that UNH, this whole chart and everything has changed to UNH. Now, here's another one. This one's a bit simpler. This will run faster. Where we've got a list of we specified a list of cities: New York, Los Angeles, and Chicago. And we are getting the population data since the start of the city, I guess it looks like, because it says all population data since the 1700. So the 1st of January 1698, the first record that we've got for New York, there were 4,937 people. And we can change this to Chicago. So their records started in 1840, 4,470, etc., etc. So we can deploy these things to the cloud. So I'll just deploy this one, for example, this population dashboard that I've created. I can deploy to the cloud, and we'll see that we've got this cloud notebook where we can change the value, and this will update. Oh, it tells you what the current population is as well. Right, APIs. So APIs are a good way to write, to integrate Wolfram language into other like web applications using GET or POST requests. So what we have here is we have an API function which takes our variable location. I don't like this default thing here because that makes it a bit more difficult to describe. So we've got our location, which is a string, and all it's going to do is it's going to return a string in JSON format of the temperature of the location is in Celsius. So when I run this temperature API, I haven't deployed it to the cloud yet. I didn't specify default values, so it says there's no value for location. So what I can do is I can set the location to London. And it's just downloading some fine location data at the moment, and it will give me the string. The temperature in London is 60 degrees. So when I deploy this, and I click on this API, what we'll find is it returns this this JSON object. Can I zoom in? Which is quite useful because it tells you, this is where it makes it much easier to integrate into your own applications, your own web applications, because it uses a kind of a standard form. It gives you a failure reason. It tells you that location needs to be, it's a field that's required. It gives you some information about it, which, you can start adding your own code to that. So, if you want to do a GET request in a web browser, you specify, you add a question mark onto the end. We can say location equals Oxford, and location equals Oxford will return the temperature in Oxford is 17 degrees. So that's how you do APIs. You can also have these APIs return HTML form. So here we are using export form to specify that we want our temperature information that we had before to be. We're adding some HTML code here, which we're adding a paragraph with style. We're adding a color and a font size, and we're wrapping it around export form to HTML. And then we are, it's also going to be returned as a JSON as well. So when I run this, and this time it's set the default location to Oxford. We've got the temperature in Oxford is 17 degrees. Now we can also create APIs which generate new notebooks. So this example uses the generate document function to we've got a function called create notebook, which uses generate document to create a notebook and deploy it to a brand new cloud object, which has permissions to public, so anyone can access it. When I run this in locally, we generate our hello. It creates a notebook with just the words that I placed in it. I click on this link. It's got a notebook which has hello in it. And we can have an API function which spits out new notebooks. So what this does is it, provided that you've given a parameter data, it cloud deploys the new notebook, and then it does an HTTP redirect to that notebook. So when I click on this, it's going to change to hello world because I've specified this as hello world. But what I could have done is I can copy this. Can I copy this URL? I copy this URL and say question mark data equals testing, and this should create a new notebook with the word with just the word testing in it. So if you wanted to create dashboards on the fly, you can use this. Use this technology. Now, in terms of delivery of these dashboards or reports, however you want to call them, we can add some additional information. So we have our dynamic module from before, but this time we want to add an additional piece of information, which is a button which sends the results of the current stock data. So what it looks like is our original plot from before. We've got a left menu, our content, it's updating. It's updating all the time. We can push this send results button. And what it should do is it should send that information to to my email address, because I've set the requester ID to the recipient to be the requester ID. So let me just see if my emails have updated. Yes. So this was I pushed the button 3 times, so I got 3 emails with the current value of that stock. So running a little low on time at the moment, so let's quickly go through these things. Although I guess we're pretty close to the end. This is a very similar type of delivery. It's instead of having a button which sends an email, it has a button which exports the notebook to exports the same information but to a text file. So I won't go through that. And then troubleshooting. Now, I'll just touch on this very briefly. The Wolfram Cloud does lag behind some of the features in that are on the desktop. So the desktop is like full support. If you're using Wolfram Desktop or the CDF player, everything will work. However, if you're using the cloud, there will be some limitations. We are improving every day. We are improving the number of functions which are supported in the Wolfram Cloud. And there are some actual like legal limitations as well. For example, financial data within APIs or forms are not compatible, and they never will be. And this is a restriction on using that financial data. You can use it in the cloud, you just can't use them in APIs or form functions. So this form does not work. What you'll find when you click on this link is when I give it a company, it's going to tell me missing, not available, and the reason why is because of that restriction I mentioned before. Now, one thing that forms do is because it was designed to have like maximum efficiency, to not rely on cloud notebooks at all. And because of that, the return is like supposed to be like pure HTML, which means some functionality will not work there. So it's important for you to be able to test those things out yourself and figure out what does and doesn't work. So finally, I won't go through this in like loads and loads of detail. You have the notebook yourself, but we're making an advanced example here, which basically takes a word and creates a little page about the word. And first of all, we create a function to be able to create an association with our word information. So when I run this, we're going to get the definitions of the word, the hyphenation, the phonetic form, the parts of speech, some Wikipedia data on the word, synonyms, antonyms, similar words, or the five similar words. So when I run this and I use the word test, what we should get is definition, hyphenation, etc., etc. So there's some Wikipedia information. Well, there's various times that the word test has been used in arts and entertainment. Now we're going to create a function which is called dictionary definition, which creates a stylized page. So don't worry about too much of this data. A lot of it's just form is these columns and rows that you've seen before. It creates a list, well, basically a column where it gives you the hyphenation, the phonetic form, and a way to hear the pronunciation of the word. It gives you the parts of speech. It gives you some definitions of that word, the Wikipedia summary here, and then all of this is stylizing information. And there's if it's missing, then give some additional information, synonyms, antonyms, similar words, and yeah, some additional stylizing information. And this thing is wrapped around monitor. So monitor is a way to show like some kind of progress. The progress indicator is going to be a necklace. And when we run this piece of code, what it's going to do, it's got that necklace, finding about the word 0, and it creates our page. And it's got a little button here to hear the pronunciation of the word. It also has a link to open to Wikipedia, where we can find the definition of the word, the Wikipedia article of the word 0. So yeah, that is the end of the presentation. Hopefully you enjoyed it. Hopefully you learned something. So in terms of what you could do next, in terms of specifically being able to like links to the information, the stuff that I showed you today, obviously you have this notebook available to you. The download link is pasted somewhere for you. So in terms of building dashboards, we've got tutorials, guide pages, workflows on creating web pages. If you're new to the Wolfram language, we've got a bunch of links here to learn about the Wolfram Cloud, WolframU courses, information on the latest features of the Wolfram language, and yeah, that's it. Now, if you're interested more in the report generation side, so what I've shown you more is to be able to develop these dashboards and add some interactivity to them. But if you're interested more in reports, there's a talk next week on the 24th, on Tuesday, where I will be talking about notebook templating, which is a package that I developed specifically being able to create reports from templates, because all this stuff did not use any templating whatsoever. Whereas you may want to be able to create reproducible reports from a template, where you specify a list of changing values essentially. So yeah, that talk is next Tuesday. I recommend that you go if you're interested in report generation. Also, I made it, so the good news about that is I will be able to answer absolutely any question in any amount of detail relating to that. So yeah, great. Well, thank you very much for listening. Are there any questions at all before we close this presentation? If not, well, thank you very much for listening. I really hope you enjoyed it. Thanks again.